next section, 8.4, trigonometry substitution. Again, I'm not cover 8.3 trigonometry integral, but make sure you try to memorize the formula that I gave it to you last section from 8.1. We're gonna use a lot of trick in this section. So let's review ourselves. Some of the trig function here is, the first one is cosine squared theta is equal to 1 minus sine squared theta. Secant squared theta is equal to 1 plus tangent squared theta. Tangent squared theta is equal to secant squared theta minus 1. Alright? I would like you to read page 533. Right? We're gonna go to one example. This is the property that we're gonna use. We will cover one example and we'll do some more during the class time. So let's look at the first one. All right, for an integral involves square root a square minus u square. A here is your constant. All right, a here is the constant minus u square. U here can be either variable or expression. So you're gonna let u equal to a sine theta. So let's look at example here. Right, I have an integral of dx over x squared square root 9 minus x squared. Okay, look at under the radical here, you have constant, which is 9 minus x squared. It's probably work, the first formula would work because you have a squared minus u squared, as you can see. The second formula is a squared plus u squared. We don't have plus there, so the second will not work. The third property here is u squared minus a squared. U is the expression and a is the constant. So we cannot use this one because the variable comes first and then minus the constant. So the most likely we're gonna use the first formula here. So if we're gonna use the first formula, because we have 9 minus x squared, so your a would be 3 because a squared equal to 9. So your a will be 3. So instead of x, alright, because I don't want to confuse this with this, I'm gonna call x, instead of u, I'm sorry, I'm gonna use x. X is equal to a sine theta. Here, a sine theta. Alright, so again your a is 3 because 3 squared is 9, so x equal to 3 sine theta. Then I'm just solving using algebra here. Sine theta is gonna equal to x over 3. Now we're gonna use this to find the right triangle. We have a right triangle here. Theta is over here, sine is opposite over hypotenuse, so x is over here, opposite of the theta over hypotenuse, which is 3. Alright, so the part that we are missing is right here, but we can use the Pythagorean theorem, if you recall, to find this part. I call the question mark here. So this part would be square root of square of hypotenuse minus x squared, which is square root of 9 minus x. So this is the length right here. Now we have all sides, we can find any trig function. For example, if you want to find cosine theta would be square root of 9 minus x squared over 3. The idea is we're going to convert all this to a trig function. Alright, that's the goal. You're gonna have to figure out what is your dx, what is your x squared, and what is your square root of 9 minus x squared, and convert all this to a trig function. Okay, so we know that this triangle here, so 3 cosine theta, I'm just multiply this by 3. So I have square root of 9 minus x squared is equal to 3 cosine theta. Alright, and if my x equal to 3 sine theta, dx, so you take derivative, dx would be 3 cosine theta d theta. So look at the asterisk here. I have dx, it's right here, x, I have it right here. Square root of 9 minus x squared, I have it right here. I have everything. 1, 2, and 3. Now I can do the substitution. So let's go back to the original function. I have an integral of dx divided by x squared times square root of 9 minus x squared. My dx, I already solved for it. It's 3 cosine theta d theta. My x squared, my x is 3 sine theta, so square will have 9 sine squared theta. Square root of 9 minus x squared, I already solved, it's over here. So I'll just put it here, right? Next step, what I did is I cancel 3 cosine theta, right? Then I pull out the 1/9, took it out, all right? So you left with integral 1 over sine squared theta d theta. 1 over sine squared theta, 1 over sine squared theta is equal to cosecant squared theta. You remember the trig, right? Trig function. So I'm taking integral of cosecant squared theta is negative cotangent theta plus c. However, we have to substitute it back. We cannot leave it as a trig function. So you go back to the triangle here. You have to figure it out with the cotangent theta. Cotangent theta, theta is over here. Cotangent theta is square root of 9 minus x squared over x. And then I'm just rewrite it as everything over 9 over x plus c. Alright, see you next section.